Look at this question. A thin rectangular polarizer P1 with x-axis is kept at the origin. P1, here it will be with x-axis as the path axis. Something is left over here. The thin rectangular polarizer with x-axis as the path axis is kept at the origin. Another identical polarizer P2 with z-axis as the path axis is kept parallel to P1 at y equals to d. A half-wave plate is introduced between P1 and P2 with optic axis making an angle 45 degree with the path axis of P1. An unpolarized light propagating along y-axis is incident normally on P1 from left-hand side. What would be the state of polarization after P1, half-wave plate, and P2? We have to solve this. Let me first draw the diagram. So this will be the figure. This is, say, this is y-axis. This is, say, I'll call it as x, and this is z, right? So here the path axis is along x-axis. P1 has got path axis along x. So light which will be coming after P1 will be having the vibration along the x-axis. This is P2 with the path axis along z direction. This is the path axis of P2, right? And the optic axis of half-wave plate makes an angle of 45 degree with the path axis of P1. Let's see what is happening in xz plane. See, whatever will happen, it will happen in xz plane. You have propagation in y direction. So after P1, your electric field will be written as, I'll draw the electric field as, electric field will be along P1. I am taking x-axis. The path axis of P1 is along x, right? So the field vibration, the light which emerges after P1, it will be having the field in this direction, right? It will be having the field in this direction. So if I call this E equals to, say, E naught sine ky minus omega t, right? Now you have placed the optic axis, half-wave plate, optic axis is along, let me call it, the optic axis of half-wave plate is making an angle of 45 degree with the path axis of P1. Optic axis of half-wave plate makes an angle of 45 degree with the path axis of P1. This was the path axis of P1, right? Then what will happen? This half-wave plate, the light will fall on the half-wave plate, making an angle 45 degree with the optic axis of half-wave plate. Then this light which will emerge after the half-wave plate will remain plane polarized. Light which will emerge after the half-wave plate will remain plane polarized, but the field vector will turn from 45 to 180 minus 45, that is 135. Now the field vector, now the electric field of the light which is emerging after half-wave plate make an angle of pi minus theta with the principal section of half-wave plate. Earlier it was making an angle of 45 with the principal section. Now I will make an angle of pi minus 45 with the principal section. So it will be like this. The electric field will be electric field of the light which is over here, which is the plane polarized light which will emerge from half-wave plate, will make an angle of 135 with the principal section, or that is along y-axis. So this is x, this is z. So I write it as z-axis. Sorry, this is z, right? This is z, xz plane. So the electric field will be vibrating along z-axis. Electric field will be vibrating along z-axis, and you have your path axis of P2 along z. So the whole light will come out of the P2. There won't be any drop in intensity. The whole light will come across P2 because the path axis of P2 is along z only. Path of P2 is along z only, right? Now I'll go for the next question. See this question. A beam of plane light falls on a polarizer which rotates about the axis of the ray, means axis of the along the direction of propagation, axis of the ray with angular velocity omega. Find the energy of light passing through the polarizer per one revolution. Right. Suppose initially the field is lying in this direction. The field is propagating, field is vibrating along this direction. I'll call it E naught sine kz minus omega t. Right. And suppose the path axis of polarizer is also in the same direction. Suppose path axis of the polarizer is also in the same direction. Right. Now polarizer is rotating with an angular velocity of omega. So at time t, your polarizer, the path axis of polarizer will be here, make an angle of theta with the direction of vibration of the field, right? And that theta is omega t. So the amount of light coming out of polarizer will follow Malus law, that is cos square omega t. Because see, Malus law goes apply for intensity, so this will apply for the flux also. Intensity, energy falling per unit area per unit time, and this is energy falling per unit time. So it will hold for the power as well, flux of energy as well. And if you want to find the energy which is coming out per second, then this will be equal to phi dt, and the time period is 2 pi by omega. So this will come as 2 pi by omega phi square cos square dt d. And integral of cos square omega t dt is basically t by 2, that is pi by omega. So this will be phi naught pi by omega. This is going to be the intensity of light, the amount of light coming out per second from the polarizer per one revolution, energy of light coming out per one revolution. In one revolution